Okay, so what do you do when you don't like the Harbor Freight charge controller that can only handle 4 amps? Well, you take it apart and you say, well, some of this stuff I might use for another project, and then you build a much stronger one that can handle 15 to 20 amps. And here it is on the breadboard, and here it is on PCB, and I'm going to show you how it works. As you can see, it's built with an Arduino microcontroller there in the middle. You see the whole complete breadboard circuit here, and I have a current sensor and a temperature sensor chip here. So basically, I scrapped the I saved the back end of this. You can see, and I pulled out the 4 amp fuse, and I saved these hookups. And basically, I 3D printed this front end panel here, and you can see over here there's 5 LEDs to show you the state. It's showing you right now the solar volts. There's nothing coming in the input, but the battery is about 12.54 and the charging is off. So I'm going to simulate some charging here by taking my power supply and hooking this thing up. So we got 15 volts on my power supply, P-channel MOSFETs, and going directly into the battery. So it's showing you here that the solar volts is 15 and the battery voltage is going up. It's charging right now. Okay, so that should say it's off. And as you can see, it shows it's off. The battery is no longer charging. So now really the load is on, which I can show you that. Okay, so we have a fan, which is only about 2 amps, or 0.2 amps I should say, hooked up to the load. My charge controller, it will show you the solar volts, the temperature, the battery voltage, and then when there's a load connected, it will show you the amps. So let me take this thing apart so you can see the inside. And here it is on the breadboard. So we have the fuse going into the diode. This can handle apparently 20 amps, 10 on each leg apparently. And then we have P-channel MOSFETs here. And then we have 2 NPN 3904 transistors that control the MOSFET for charging and a MOSFET for the load. And here we have a Hall effect sensor. It's a current sensor. And then we have some LEDs and some resistors that make up the voltage divider. We have a diode here that can suppress the high voltage, like a lightning strike or something like that. And then on this little breadboard, I took it apart already, but I had the Arduino Nano on here, and then I had the OLED display here. So, and the finished product, of course, is inside this unit here, which I will open up so you can see that. Fritzing, and it's my favorite program. Let's get in here and we'll show you how I use Fritzing to make the PCB. And it only had 2 jumpers, so it's a single side PCB here. There it is. And that fits perfectly inside the Harbor Freight enclosure. You can see the Arduino Nano goes there, the output to the OLED goes there, there's outputs to my LEDs, there's a voltage divider, there's the diodes and the MOSFETs, and then here is a switch mode power supply, and basically there's the back end that will tie into the back end of the Harbor Freight unit. So there you have it. Fritzing, and it's my favorite program. Let's get in here and we'll show you how I use Fritzing to make the PCB. And it only had 2 jumpers, so it's a single side PCB here. And that fits perfectly inside the Harbor Freight enclosure. You can see the Arduino Nano goes there, the output to the OLED goes there, there's outputs to my LEDs, There's a voltage divider, there's the diodes and the MOSFETs, and then here is a switchboard power supply. And basically there's a back end that will tie into the back end of the Harbor Freight unit. So there you have it.